Hi everyone, I'm Akshan Gopal. I'm in AP Physics 1, taught by Mr. Higgins, and I'm about to do a problem based on a learning objective. And my learning objective is 1.B.1.2, and it states that the student is able to make predictions using the conservation of electric charge about the sign and relative quantity of net charge of objects or systems after various charging processes, including conservation of charge in simple circuits. So basically my problem is that there are two charge particles that are fixed in place. One of them is x1 and another one is x2. Now we know that x2 has a larger magnitude of charge than x1. So basically what we have to do is find a third charge in any of these A, B, C, D, or E points, which may contain a third charge which would make the net force on the whole system to be 0. So for part A, both these particles are positively charged. So to get the net force, the force due to x1 must be the same size as the force due to x2 on the charge, but these two forces must point in opposite directions because of the charges. So if the charge is placed at points A or E, then both the charges will push it to the left. So if we place a negative charge there, the other charges will pull it to the right. So it's not possible for the net force to be 0 at these points, but between x1 and x2, two forces from a third charge will point in opposite directions, so we need to find a position where these opposing forces are the same size. Now point C is the same, Q2 is a larger charge and it is closer. At point B, so if x1 and x2 were the same size, the force due to x1 would be the greatest, but we know that x1 is smaller than x2, so it's at least possible that the forces are equal at these points. So our answer for this is B. Now moving on to part B. Now x1 is positive and x2 is negative. So for points B, C, and D, the force on the third charge due to x1 being pointed in the same direction, the forces will point in the same direction as the force due to negative x2. At point E, the forces will be in opposite directions, but the force due to x2 will be larger, since this is a larger charge and is closer. So at point A, the proximity of x1 might compensate for the smaller charge in just the right way, so that the forces due to negative x2 and positive x2 are equal in magnitude. So for this problem, we choose the answer A. The forces on the third charge will also point in the same direction, so it's not possible for both forces to add to 0. Now at point E, the larger charge is also closer, so the force due to the larger charge must be larger. So at point A, the smaller charge is also closer, so it must be possible. Yeah, no. So it must be possible for the two forces to be equal and opposite. So for this, we choose point A as well. Last one.
What?
Last.
Okay.
Now, last but not least, both x1 and x2 are now going to be negative. So as with question A, the forces act in the same direction for the charges placed at A or E, and at point C or D, both forces cannot be the same magnitude, obviously. And at point B, the forces point in opposite directions, and the smaller charge is also closer. So it's possible that the net force is 0 on a third charge placed at this point, which is B. Thank you for watching. I hope you found my video informative, and I hope you have a good day.